stomach. But with your glucagon, that is that very hyperglycemic agent. So it kind of like produces that glucose, right? And this is triggered by a decrease of glucose levels in the blood, which would make sense because if you already have high levels of glucose, the glucagon would not want to be released. That hyperglycemic agent would not want to be activated because then you would like drastically increase the amount of glucose. It's also triggered by rising amino acid levels or the sympathetic nervous system. So it goes back to that fight or flight, that kick of adrenaline that can override these cells and get them to produce that excess amount that you normally wouldn't want for that certain situation, whatever that trigger is neurally. But this obviously will raise your blood glucose levels, and it will target your liver, and it does so by breaking down glycogen into glucose. So glycogen is really how glucose is stored. You don't store glucose in your body as glucose. You store it as glycogen. And your body will break down that glycogen into glucose for use. And this is called that glycogenolysis. So lysis is like breaking down. And you synthesize glucose from lactic acids and other non-carbohydrates. That synthesis is gluconeogenesis. So you've heard gluconeogenesis is that forming of glucose from proteins or other fatty acids, whatever it may be. But then that gluconeolysis is the breaking down. That's what your liver does. That increases the blood glucose concentrations or blood sugar concentrations. And so it releases, then you get into your beta cells, and these release insulin, and it pretty much counteracts. So it's really in this cycle. So the beta cells are going to release insulin due to high levels of glucose. And it lowers the glucose concentrations in 3 different ways. It first enhances the membrane transport of glucose in fat and muscle cells, because your glucose is that lipid soluble, so it can't dissolve. So if you have that enhancement of transport, it can connect to those like fat and muscle cells. It helps take away from that concentration in the blood. It will lower that the blood sugar levels. It will also inhibit the breakdown of glycogen into glucose, because if you look at this cycle, you have these alpha cells that are going to release glucagon, but if the liver can't break them down into glucose, you won't have an increase of your blood sugar or blood glucose levels, so then it won't be a problem. The third way is it inhibits the conversion of amino acids or fats into glucose. So that gluconeogenesis, if that process is stopped, if you never turn the amino acids or fats or whatever into glucose, you won't have that increase of glucose in your blood system. You won't have that high concentration build up. And so that's what you really see when you get to, like you have adipose, take up this glucose, you exercise, you use that glucose, because glucose is pretty much a 6-carbon molecule that goes into the cell's metabolism. It goes through glycolysis, Krebs cycle, electron transport chain, and what you end up with is ATP, which your body uses, which is why exercising uses up glucose. It uses up that body's sugar. And that's why you have that secretion, that release of glucagon, like after you exercise or when you're exercising, because your cells are going to be taking it all in. It's going to decrease that concentration, and then those alpha cells are going to go like, oh crap, we need more, we're pretty low, and they're going to send it to that liver, breaks it down to glucose, and it continues on that cycle.